Okay, so we know the heart so far is this cone-shaped muscular organ and is hollow. Remember, we have the four cavities or the four chambers inside, two superior chambers, atrium, two inferior chambers, the ventricles, right and left. Now, when you see it from the outside like that, okay, you can see here the muscle, right? The myocardium, but you cannot see, but in there is the epicardium, whatever. The thing is that we're going to see some landmarks or some external markings that let us know with the heart like that, closed without being dissected, where the atrium and where the ventricles are. Now, you can follow me, and usually is where the blood vessels are located. All of this groove or sulcus is called the coronary sulcus because it's where the coronary blood vessels or the coronary arteries are. And that is an external landmark that lets you know that superior to that line or to that groove, we're going to find the atrium, and inferior to that groove, we're going to find the ventricles. Now, we cannot, right in the middle, you have all of these, the great blood vessels, the aorta and the pulmonary trunk, and that is letting you know, well, this is the right atrium and this is the left atrium inside, because these flaps are not the atrium. These are actually expansions of that chamber. We're not going there. We're just saying that we're trying to see through the wall of the heart to figure where are the chambers inside located, okay? So in there, inferior, or if we cut the heart through here and we make an opening, we will see there the right atrium. You will make an opening in here, we will see in here the left atrium. Now, the ventricles are, if you follow this artery in here, is located in another sulcus. Remember, a sulcus is just a groove, okay? And this one separates the right ventricle from the left ventricle, okay? So if you cut in here, you're gonna get to the right ventricle. If you cut in here, you're gonna get to the left ventricle. This is called the anterior interventricular sulcus. Anterior because this is the anterior view of the heart, or the anterior surface of the heart. And interventricular because it's located in between the ventricles. Now, this is a posterior view, okay? And in here of the heart. And in here we can see some of the veins arriving at the atrium. See how they open? These two blue ones are opening on the right side. Now this is the right side, the right atrium. And these four veins are opening into the left atrium. And we can see another groove or another sulcus, which is this one. Again, follow the red blood vessel in there, that red artery. And that is called the posterior, because we're in the posterior surface, the posterior interventricular sulcus. So this is the right ventricle and this is the left ventricle. See that in here right looks bigger, but in here the left one looks bigger. It's because, again, the orientation of the heart within the thoracic, within the mediastinum. But we will see inside actually what is the real size of those chambers, okay? So now we're gonna cut it, and this is a coronal section, right? So we can see, we remove the top, this, we're gonna cut it like this, we're gonna make a slice and we're gonna cut it open. So these are the cavities that we can see now, okay? And these are the four main chambers. Two superior, remember the atrium, they receive blood, okay? So this is the right atrium, this is the left atrium. Remember, in anatomy is the right and the left or of the subject or the organ, not your right or left. And in here we can see the right ventricle and the left ventricle. And remember, those are the chambers that pump the blood towards these blood vessels. Okay? Now, to explain you this, I prefer to use, this is how I do it in the classroom. I always draw my big heart. I love you guys. Never tell you that, but I love you. So, of course, we know this is not the shape, but it makes it fun. So, we have 4 chambers, right? We said that we have 2 superior atrium and 2. This is your right atrium. This is your left atrium. This is your right ventricle. And this is your left ventricle. Okay? So let's describe what do we have in each of these chambers. And before going there, I'm going to tell you that your right heart is blue. 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 And your left heart is red. Red. Okay? Now we can go and let's go in black. Now, the right atrium, we know is a receiving chamber. So it receives blood from a blood vessel, right? Actually, in here we have 2 blood vessels. I'm going to put one in here and one in here. And is this a blood vessel or an artery or is a vein? It's getting to the heart. So it's a vein, right? And it's called the superior vena cava. And this is the inferior vena cava. So these veins are just draining blood, collecting the blood from all your body, the superior and the inferior portions of your body. And this is deoxygenated blood. This is blood that already, it delivered all the oxygen. Now it ran out of oxygen. Now it has to go back to the heart to empty that blood, deoxygenated blood in the heart, so we can blue deoxygenated blood, so we can eventually go to the lungs. Now, we need that blood to pass to the right ventricle. So let's open here a communication in here. And this opening is actually a valve, okay? I'm gonna put it like this. 1, 2, and 3, okay? And this valve, what is a valve? A valve, like the valves in the hose, the water hose. A valve is something that regulates the passage of a fluid from here to here, right? So this valve is regulating the pass of blood from the right atrium to the right ventricle. And at the same time, when this valve closes, avoids the backflow of this blood into the right atrium. So we keep all the blood after it fell in the right ventricle by gravity, it closes and avoids the movement of blood back into the right atrium. That's the function of of valves. And this valve is called tri. Why tri? Because we have 1, 2, and 3 flaps or cusps. So tricuspid valve. Okay? We also can call it right atrium ventricular valve. Right atrium ventricular valve. Okay? 2 names for 1 valve. So blood, let's follow the flow of blood. Blood is flowing right through the veins are emptying the blood right here into the right atrium. Right atrium is filling with blood. Okay, so this blood is going to pass through this valve, the tricuspid valve, and enters right here into the right ventricle. Now from the right ventricle, we need another exit. But remember, ventricles are pumping machines, right? Are the ejectors. So I'm gonna put about here, another valve, okay? And this is called a semilunar valve. I'm gonna put it here. Semilunar valve. And since this semilunar valve opens or leads to a blood vessel, okay, that is getting out of the ventricle, out of the heart. So what is this? Is this a vein or an artery? It's an artery, okay? And this artery, so I want to make my point, is carrying deoxygenated blood. So it's blue artery, okay? So and that artery is going to the lungs. There are about, let's put it here, of course, not in perspective. This is your right and your left lung, okay? So this artery, which is called the pulmonary trunk, divides into branches, and one for the right lung and one for the left lung. So this valve, there is connecting the right ventricle to the pulmonary trunk, is called pulmonic or pulmonary valve. Okay? Now, this deoxygenated blood finally reach the lungs, the right and the left lungs. And here in the lungs, remember, we have a lot of oxygen. That's what we have because we're inhaling air, right? Air full, hopefully full of oxygen. So as this deoxygenated blood passes through the lungs, okay, it picks up this oxygen in here and becomes now oxygenated blood, okay? And this oxygenated blood is going to return now to the heart, okay? But to the to the left side, because I told you the left heart is red, okay? And the right side is blue. So it's returning this rich in oxygen or oxygenated blood is returning to the heart. Since it's returning to the heart, how do you call the blood vessels carrying that deoxygenated blood? Oxygenated. How do you call them? Veins. And since they are coming from the lungs, two on the right side and two on the left side, well, two on the right and two on the left side, we're going to call them pulmonary. Is that the heart? Pulmonary veins. And why veins? Because they're going to the heart, okay? So, but they are carrying, again, making my point, they're carrying oxygenated blood, but towards the heart and reaches the left atrium. Now we're in the left atrium. We need, and again, to open a communication between the left atrium and the left ventricle. And, well, we call this right atrioventricular valve. We can call this left atrioventricular valve. And this one has only two cusps. Remember that this one has three, this one has only two. So we call it bicuspid valve. Also called, this one has three names, your mitral valve. Woo, that was a parenthesis. Okay, so left atrioventricular valve, bicuspid valve, or mitral valve. And the function, again, just allow the movement of blood, oxygenated blood, from the left atrium to the right ventricle, and avoids the backflow of blood from the left ventricle back into the left atrium. Okay? And well, now we have all these oxygenated blood in the left atrium. Let's get it out of the body. I mean, the heart. And for that, we need another blood vessel that we're gonna put in here. And this one also, since it opens to, I'm gonna put it like this. Wow. I hope you understand something on my picture, but I'm not that good. The thing is that since this valve is opening into another blood vessel, that is getting the blood out of the heart. So that is an artery, right? Because this is the direction of the flow now. Okay, so it's carrying the blood out of the heart to be delivered throughout all your body. The name of this artery is called the aorta, okay? And the name of the valve that opens into the aorta is called the aortic, or yeah, let's put it here, aortic semilunar valve. Yeah, this is giving me quite some trouble to write with. So aortic semilunar valve, okay? So what we have described? We have described 4 chambers. What are the name of the chambers? We have right atrium and left atrium. Now, these 2 atriums are separated by an inner wall that is called Interatrial Septum. Let's see if this interatrial, gosh, Interatrial septum, okay? And then we have 2 more chambers. These are the pumping chambers, the ones that pumps the blood out of the heart, and those are the ventricles, the right and the left ventricle, and they are divided by this inner partition that is called interventricular septum, okay? Now, the right atrium receives blood from the superior vena cava and inferior vena cava, and receives deoxygenated blood. Another important fact that we can find here that I didn't describe in the right atrium is right here in the interatrial septum, that wall separating the right from the left atrium. It's a scar. There is called fossa ovalis. When we were in mommy's belly, these 2 atria were communicated through a hole that is called, or was called, foramen ovalis. Foramen opening, ovalis, oval in shape, and used to communicate both circuits, the blue one and the red one. When we were born, right at the moment of you taking the first breath, that moment, because of changes of a change of pressures in there, it closes that valve, and that valve no longer exists in our postnatal life. And what we have is a remnant, a scar in there that marks the place where once these 2 chambers communicated. Now, there are some people, few is common actually to find, I don't know, maybe 15-20% of the population has this opening still. The foramen ovale didn't close, no problem whatsoever. Sometimes you can hear a heart murmur, but it doesn't cause any trouble as long as it's not constricted. Okay. Well, I don't know why I went there. Then, so those are the four chambers. How many valves did we describe? Four, two atrioventricular valves, the right atrioventricular valves or tricuspid valve, because it has three cusps between the right and the left, and the right atrium and the right ventricle. And the left atrioventricular valve or bicuspid valve, because it has two valves, also called mitral valve, between the left atrium and the left ventricle. But we also describe two semilunar valves. The pulmonary semilunar valve is found on the where the right ventricle opens into the pulmonary trunk, and the aortic semilunar valve where the pulmonary where the left ventricle opens into the aortic or into the aorta. Okay, so I'm gonna go back so you can see in a beautiful drawing all of these chambers. So right atrium receives blood from superior and inferior vena cava. Okay, these are the openings. And this is the fossa ovalis, okay, that I told you before, the scar. This is one of the flaps of this valve. This is in the right side. This is the tricuspid or right atrioventricular valve that opens into. This is the right ventricle. Okay, remember all of this is blue. Your right chose red. The right heart is blue. So all of this is blue. Now this right ventricle pumps the blood or ejects the blood to the pulmonary trunk, passing through the pulmonary semilunar valve. And this pulmonary trunk divides into the right and left pulmonary arteries, yes, that carry the blood to the lungs. Lungs in there oxygenate the blood, and this blood now is returning to the heart. Okay, now we have oxygenated blood returning to the heart through veins, of course. Okay, and we have four veins that open in the posterior aspect of the left atrium. We can see the opening of these two arteries, these two veins, and about here, behind this, behind the pulmonary trunk, we will see the opening of these two pulmonary veins. Now we are right here in the left atrium. The left atrium opens or empties the blood to the left ventricle through the mitral or bicuspid or left atrioventricular valve. Once in here, the blood is ejected through another semilunar valve, but this one is called aortic because it opens into the aorta, which is this huge artery. So that's the aortic semilunar valve. And this aorta, as you can see, it curves, it creates an arch and descends posterior to the heart. This is the same blood vessel. Now, one more thing that I want to describe in here, look at the wall of the atrium thin because they are receiving blood, okay? They are getting distended with blood. When the weight of the blood, it's like putting liquid through a paper. When the blood is heavy, enough, it just opens both the atrioventricular valves. And now compare the wall of the ventricles. In general, it is thicker than the wall, the myocardium of the atrium, because this one needs to contract against a resistance, a pressure of found in these blood vessels. Okay, so we need to eject, we need more force of contraction in here in order to pump the blood, open this semilunar valve against gravity and against the pressure present in these blood vessels, blood present in these blood vessels, and that's why these walls are thicker. But now compare the wall of the ventricle in the right side and the one in the left side. And you can see that the one in the left side is way thicker than the one in the right side. Again, the right ventricle pumps blood towards the pulmonary circuit. So the resistance that we're going to find in here is only the one of these pulmonary trunk and the blood vessels that goes up to the lungs or to the lungs. But so it's a circuit of low pressure. But the left ventricle has to pump blood against the pressure that we have in the entire body, against the pressure that we have in the aorta and the resistance that to eject blood against the resistance of all the organs in the rest of the body. So we're pumping blood against a major resistance circuit. This is a higher pressure circuit, and this is why this muscle is bigger, it's not hypertrophic, it's bigger than the one in the right ventricle. Now, this makes the right ventricle wider, bigger than the cavity of the left. They both manage the same amount of blood, exactly the same amount of blood, but this one is built to manage the volume, just to get the volume and send the food to the lung, go and food send it to the lung. But the left ventricle, even though it receives the same amount of volume, it receives the volume and then it has to contract really, really powerful contraction to pump it against to open the aortic semilunar valve into the aorta. Next video, I'm going to talk about a little bit the valves.